Okay, so I am just going to look at balancing equations. I'm instead of showing it like this, I'm showing it over here, just trying to find a way to make things usable for drawing stuff out. So this is the equation that we came up with for the hydrogen and selenium produce hydrogen selenide. We have that there. Um, and the standard way to kind of check balancing stuff out, this is no big secret. This is a real common way that people do it everywhere. We would just kind of say, hey, how many hydrogens, how many seleniums on this side? Excuse me. And then we check how many hydrogens, how many seleniums. Oops, I forgot to put my E up there. Durr. Uh, on that side. So we have those things taken care of. And when I'm checking the hydrogens here, that little subscript 2 goes for that. So we have 2 hydrogens in every packet that they come in. Remember that subscript 2 means that these hydrogens come in pairs. They just come stuck to each other. This selenium, there's just one of them present in this format, and that's that. If we want more of them, then we put those, we add or change the coefficient out front. And that coefficient just tells us how much of that stuff we have. It doesn't change what it is, it changes how much of it we have. So then when I go over here, and I'm just doing my accounting right now, so this little subscript 2 goes only for the H. That means in every packet of hydrogen selenide that we get, we have 2 hydrogens. The selenium ion, there's no subscript there, but if there's no subscript, that means there's 1. So I have 1 there. So before we start doing coefficients, we just do a quick check. 2 hydrogens here, 2 hydrogens there. Hydrogen balanced. Selenium, there's one there, selenium balanced. So if we have the same number of selenium particles on each side, we have the same number of hydrogen particles on each side, we're set. We're done. That's it. This one, balanced. Check. Okay, checking the balancing equation part for the carbonic acid plus barium hydroxide produces barium carbonate and water. Carbonic acid and barium hydroxide produce barium carbonate and water. So going through, and it's the same sort of accounting sort of things that we did before. I can check how many H's I have, and this carbonate, pardon me, this carbonate is a group. So I'm just going to do that whole group here. Barium, floop, hydroxide. That barium is a little bit sloppy. I am actually going to correct that. Well, not correct it. I'm going to make it look party, or at least better. Now going over here, I'm just going to do the same sort of checking, and I'm going to try to put them in kind of the same sequence. It's barium here. I'm going to put that at the same height. We have that carbonate ion. I'm going to put that here. Hydrogen and hydroxide. So if I just go through and check how many of each of them I've got, well, here, this hydrogen starting here, it comes 2 hydrogens with every carbonic acid formula unit. So I can say there are 2 of those. This carbonate in carbonic acid, there's 1 of those in every unit of that. The barium here, there's just 1 of those. This 2 goes for everything inside the parentheses, but not beyond that. So this barium, there's still just 1 of those. And then here we're looking at this hydroxide. There's 2 of that group. So real quick, like just to make sure, a weird way, an unconventional way to do this, we could say that's BaOH, OH, right? There's 2 of these hydroxide things, hydroxide ions stuck on there. That's just another way to think about what that 2 means. I'm going to get rid of this now, just to make sure we have the space to keep on going. So then we go to the product side. So this is what we started off with. That's our reactants. Our product side, I'm going to go through and just do that the same bit of accounting and checking how many atoms of each we have. Barium right there. Oops, I need to put that on the pen. I've got 1 barium. This carbonate ion, comes in a group, and we've only got one of them right there. Hydrogen there, hydroxide, there's one of them there, one here. And it's worth saying just to make sure this is out there. So when we're grouping them by polyatomic ion, that's a little bit of a shortcut, just to be clear. Really, truly, what we're generally going to be checking, or what we need to check, is like, okay, how many oxygens are on both sides? How many hydrogens are on both sides? But in an equation like this, where there's a CO3 group here and it just swaps there, and an OH group here and it just swaps there, when we have those sorts of things, then it's useful to group these things as polyatomic ions. If one of these polyatomic ions like breaks up somehow, and there's a carbon in one thing and oxygen in another thing, and there's no carbonate ion anywhere, then we need to make sure that we're taking a look at all of the oxygens and hydrogens separately. So, side sermon there. Now I can go through and I'm just going to check. We have one of everything in our product, and we have one of a couple of things in our reactants, but we have two hydrogens and two hydroxides. So if I just look at those, I have two hydrogens and two hydroxides. If I just look at those over here, well, they're both actually in this substance. So if I have one hydrogen, one hydroxide, if I just put my two right there, now I can say I've got one in each formula unit, but I've got two of those formula units. I've got two of those formula units. So now I have two hydrogens and two hydroxides in my product, just like I do in my reactant. So that's balanced. Done. The other way to do it, if we're not quite seeing that this H and this OH are both in the same thing, it is purely and cleanly and legitimately functional to go through and just say, well, I have two hydrogens here. I'm going to go over here and I'm going to put a 2 out in front to make this 2H. That's the most common, like, we're just starting out sort of approach. I maybe should have done that. So if I need two hydrogens over here, I would just put that 2 there. That gives me my 2H's. And then we would find luck is on our side. The gods are with us, because when we did that, that would also make 2 units for that. And we would find serendipitously, by chance, by good fortune, that works for both of those things, and we're set up. There you go. I hope that helps. Know that this balancing equation part is one type of a challenge, one type of a learning thing that we need to figure out. The going from names to formulas is a completely different one. So there are different types of learning processes, and this assignment puts all of that together. So yeah, this is a big challenging assignment with many different parts to it. So just give them a go, see what you can come up with, and good luck to you. Let me know if you have questions.